All right, so today's notes are on solving radical equations. Our content objective is to solve square root and other radical equations, and our language objective is to use the correct terminology to describe roots and radicals. So our first problem asks us to solve 3 plus 2x minus 3 equals 8. So our first step we need to do is isolate the radical. So that's going to be the first step for all of our problems. We always need to isolate the radical as much as possible. So to do that, I have 3 plus the square root of 2x minus 3 equals 8. I need to subtract 3 from both sides. So I have the square root of 2x minus 3 equals 5. Then I need to get rid of the radical. So these are the general steps. This is the more simple example of the general type of formula we're going to use to solve this problem, or the general procedure we're going to use to solve this problem. So please make sure you're taking note of this. We're going to isolate the radical, square both sides to cancel the radical, or we're canceling the radical as our second part. So I have 2x minus 3 equals 25. Then my last step is just to solve for x per usual. So I'm going to add 3 to both sides. I get 2x equals 28. I divide both sides by 2, and x is equal to 14. So that would be my answer in that example. So the main process we're going to be solving or using for all of these problems is isolate the radical, square both sides, solve for x. They're not all going to be quite that simple or straightforward. So some of them are going to be a little bit trickier. So I'm going to show you a couple different methods you could use to solve this next problem. So our next one says 3 times x plus 1 to the 2/3 equals 12. So I'm going to show you two different methods for this. The first method I'm going to use is the one I think that most people will probably prefer, but I'm not quite sure, so I'll show you both. So I'm going to start, I'll rewrite my problem. So I have 3 times x plus 1 to the 2/3 equals 12. So again, I need to isolate my radical, which even though it's in exponential form right now, I know that a fractional exponent represents a radical. So I'm going to start by isolating that radical. So I have x plus 1 to the 2/3 equals 4. I'm then going to write this in radical form. So I write this as the cube root of x plus 1 squared equals 4. And then to get rid of that cube root, so I'm going to rewrite this just so you can clearly see this next step. I'm going to cube both sides. So I cubed both sides to cancel the cube root and the cube. So I'm just left with x plus 1 squared equals 4 cubed will be 64. So then this is just a normal quadratic equation. I'm going to square root both sides to get rid of it. So I have x plus 1 equals plus or minus 8, sorry, not 64, I just square rooted it. So the square root of 64 is 8, but since I'm solving, I need more than just the principal root. So remember I mentioned that when we were simplifying radicals. You only need the principal when you're simplifying, but when you're solving, you need both the principal and the negative root. So now I make my two branches. I have x plus 1 equals negative 8 and x plus 1 equals 8. So I subtract 1 on both sides and I get x equals negative 9 or x equals 7. So those are my two final answers. So the general process is, again, you isolate the radical, you get rid of the root, you get rid of the exponent, then you solve per usual. So the general process, again, isolate the radical, rewrite or get rid of the root, get rid of the exponent, solve per normal. I'm going to show you another possible method that your book suggests, and in some contexts could be easier, and for some people might make more sense. So I'm going to show you this other method just in case. If you don't like this method when I show you it, then you do not have to use it. You can use the other method I've shown you, but just so you have options. So again, it starts off the same. You always need to isolate the radical first. So I isolated the radical here. What's going to be different in this problem is I'm going to multiply by the reciprocal. So I'm going to try to get rid of all of this at once. Instead of doing this in two steps like I did here where I got rid of the denominator, then I got rid of the numerator, I'm going to get rid of this all at once by multiplying the exponent by its reciprocal. So I'm going to multiply by the reciprocal. And this is not the negative reciprocal, it's just the reciprocal. So you just flip so it's 2 over 3, so it becomes 3 over 2. So then you're just left with x plus 1 as your normal left side of the equation, but now you have 4 to the 3 over 2. So then you can rewrite that as a root. So you have the square root of 4 cubed. The square root of 4 cubed is the square root of 64, which is plus or minus 8. And then you end up at the same place again. So you end up with x equals -9 or x equals 7 when you do your two branches. I'm not going to resolve that out for the sake of time, but it's the same last steps at that point. So you end up with the same answers, just instead of getting rid of the radical in 2 steps by getting rid of the root then the exponent. In this problem, you're just multiplying the exponent by its reciprocal to make it 1. So that's that example. I'm going to flip the page so you can try a quick check with one of those 2 methods. So try this on your own. It's not going to be, you're going to have a radical in your answer, so don't be worried if that's where you end up. But try it on your own. I'm going to go over it now. So I'll use method 1 first. For those of you that prefer the first method. So I have 2x minus 2 to the 3 over 2 equals 6. I divide both sides by 2, get x minus 2. Instead of writing 3 over 2, I'm going to jump the step and write the square root of x equals 3. So I just rewrote the radical in that step as well. I square both sides and I get x minus 2 cubed equals 9. Then I'm going to cube root both sides. So I get x minus 2 equals the cube root of 9. And then I add 2 to both sides. In this problem, because I don't have an even root, I don't need to do plus or minus. I can just do plus 9. So I end up with x equals 2 plus the cube root of 9. Again, when it's an odd root, you do not have plus or minus. You only have one solution. All right, so for the next method, if you did prefer that second one, I'll go over that really quickly before we do our last example. I again start the same way. So I have 2x minus 2 to the 3 over 2 equals 6. I divide both sides by 2, and I get x minus 2 to the 3 over 2 equals 3. I raise both sides to the 2 over 3, which is the reciprocal of 3 over 2. The exponent on the left side becomes 1, and then I'm left with the cube root of 3 squared, which becomes the cube root of 9, add 2 to both sides, and you have x equals 2 plus the cube root of 9, which is the same as the other answer. So as long as you were able to successfully complete one of those 2 methods, you should be fine. All right, so now we have one last example that's a little bit longer and a little bit trickier and goes back to our quadratics and all that fun stuff. So I'm going to go through it right now. I want us to solve 2x plus the square root of 2x plus 1 minus the square root of x equals 1. So right here you might notice that we have 2 separate radicals. So we don't have one radical, but instead we have 2, which makes this a little bit trickier. I can't combine, so in previous problems when we add, subtract radicals, we can simplify them and combine coefficients. We have variables under here, we can't simplify them. This is fully simplified because there's adding, we can't combine their coefficients, so we actually have to deal with them as they are. So the way we deal with this, we have 2x plus, I'm going to write the problem, 2x plus 1 minus the square root of x equals 1. I'm going to isolate the more complicated radical. So in all our previous problems, we always start by isolating the radical. Since I can't isolate one radical, since there's 2, I'm going to isolate the more complicated one. So I see this one's more complicated. So I'm going to move the square root of x. So I have the square root of 2x plus 1 equals the square root of x plus 1. And I'm just choosing to write the square root part first because I like to. It doesn't really matter which part you write the square root of x on the right side. You can write it first or second, it doesn't matter. Then I'm going to square both sides to get rid of that square root. So one thing you need to remember is that when you square the right side, you square the whole binomial. So the square root of x plus 1, that whole thing is going to be squared. So on the left side, we just get rid of the radical, but on the right side, we actually have to FOIL this out. So when I FOIL this out, I get square root of x plus 1 times the square root of x plus 1. And I'm going to keep writing this out so you can see the process, but square root of x times the square root of x is going to become regular x, and then I have plus the square root of x plus the square root of x plus 1, which becomes x plus 2 root x plus 1, and the left side has not changed. So I end up there after I FOIL. Now I'm going to isolate the radical and its coefficient. So again, I'm always trying to get the radical by itself. So here I can move my x and I can move my 1. So I'm going to move the x and I'm going to move the 1. And I'm doing this in one step. If you'd prefer to do it in two, that's fine. But then 2x minus x is 1x, 1 minus 1 is 0. So I'm just left with x on that left side. And on the right side, I end up with just my coefficient and my radical. So I've isolated the coefficient, or the radical and its coefficient. Now I need to get rid of the radical again. So now I'm squaring it again to try to get rid of this radical. So notice that in this process, I had to square it twice. So I end up with x squared on my left side. And this I have to distribute my exponent into both parts. So 2 squared becomes 4, square root of x becomes regular x. So here becomes 4, here becomes regular x. Now I'm back to a normal quadratic, but this still requires some of our previous knowledge. So in case you forgot, in order to solve a quadratic, I need to set it equal to 0. So now I have x squared minus 4x equals 0. I can solve this by factoring out a GCF. So in case you forgot, you're going to take out a GCF. So my GCF here is x, so I have x minus 4 equals 0. Zero product property, I can say x equals 0, x minus 4 equals 0. So x equals 0 or x equals 4. And those are my two possible answers. Since we have two radicals, you always want to check your solutions. So make sure that they actually give you a value that would end up giving you or having positive values underneath. So if I check 0, I get the square root of 2 times 0 plus 1 minus the square root of 0 equals 1. Becomes the square root of 1 minus 0 equals 1. 1 does equal 1, so that one checks out. Sorry, I'm going through this quickly, but I'm trying to make it relatively quick for you guys. So the next one I plug in 4. So again, 2 times 4 is 8, plus 1 is the square root of 9, minus the square root of 4 equals 1. 3 minus 2 equals 1. 1 equals 1, that checks out. So my answers work, they both are correct. So I know that's a lot of information, but we will practice it in class. Make sure you write down any questions, comments, or concerns you have on this so we can go over it.